those of you who've ever seen a video with me before have heard me talk about LV20.19 CAR T-cells. This has been sort of a major work of our institution and for myself personally. And what we've done is we've taken this dual targeted CAR that targets both CD19 and CD20, and over the last 7 years have sort of done an iterative process to continuously improve. One of the principles I believe in terms of CAR is that it's not just a construct, but how you manufacture it that can actually improve clinical outcomes. So this was sort of a multi-cohort phase 1 study. And what we did is we sort of made the CAR under different conditions. We had a group of patients that had an 8-day manufacturing process, but gave the cells fresh. We had another group of patients that had an 8-day manufacturing process, but were mandated to freeze the cells before delivery. Then we had a third group of patients that we sort of did a longer process, which was our historical 12-day process. And we looked at both patient outcomes, like these were actually delivered to patients on these arms. And then we also looked at sort of correlative data, looking at how the cells behave outside of the patient as well. I'm gonna focus on key takeaways. One of the big takeaways is that anyone who was manufactured in the shorter manufacturing, they had trends towards a higher overall response rate and higher CR rate. The patients who got fresh cells, especially in the 8-day arm, had some trends towards more CRS, but luckily nearly all of the CRS was grade 1 to 2. When we looked at these cells, again, in the laboratory, we actually did high-level sort of analysis to understand what are the differences. So one thing we did is we looked at those cells that were sort of frozen, and we analyzed them when they were fresh, we froze them down, and then we analyzed them again when they had thawed. And we found that how those cells metabolized was actually different after they were frozen and thawed. And in fact, they were not as good in metabolizing. They had decreased ATP production, how they consumed oxygen and glycolysis was all inferior. We also then looked at the transcriptome. So how is the cell sort of behaving? And again, after thawing, there were more genes that were promoting senescence and apoptosis. Those are not things you want in a CAR T product. And then finally, we looked at sort of how do the cells look if you manufacture them at 8 days versus manufacturing them at 12 days. And we found that 8-day cells tend to be sort of younger, healthier, more central memory, stem cell-like. So when we put all of this data together, we actually learned that the optimal manufacturing for this product is short at 8 days and given as a fresh product. And together, that correlated with the best outcomes for patients as well. And from a preclinical standpoint, correlated with healthier looking cells. So that was a lot of information that we packed into what is a poster presentation. But if you look at the data, there's a lot that I think all CAR people can learn from our experience of shorter manufacturing and potential advantages to a fresh product.